Hey guys, welcome back to my channel. Today is day 44 of Algorithm Challenge. Um, yeah, I'm excited that now we're done with just the overview of all the theories, starting from arrays, strings, hash maps, to heaps and dynamic programming. Now, from today onwards, we're going to go through specify each of the templates that we have for the data structures and algorithms. And yeah, briefly go through those templates. And then after we go through them to refresh our memory, we're gonna start from sliding windows and two pointers to implement them. So I'll try to solve 10 questions each for each section before moving on to the next, because I believe that in order uh, to be proficient at some kind of data structure, then yeah, you'd have to uh, keep on repeating. Yeah. Anyways, I'm going to go through the data structures, and today we're going to go through two pointers and sliding windows that we did in our first few days. Uh, I've written, well, I've got the code. Let me share my screen. Yes. So as you can see, this is um, the implementation of two pointers. So what do we remember about two pointers? We know that we have to start the pointers at the edges of the input and then move them towards each other until they meet. So we start one pointer at index 0. So that we initialize with a left when there's only one argument provided. And we started at an index 0. And the other pointer at the last index, which is length array -1. So right pointer is implemented, initialized as length of array -1, length of array -1. We try to remember length of array -1 because interview, they're not going to give us this templates, right? Yeah. And at each iteration of the loop, we move the pointers towards each other. This means either increment the pointer that started at the first index, which is left, or decrement the pointer that has started at the last index, which is right, or both. So deciding which pointers to move will depend on the problem that we're trying to solve. So yeah, that was the basics of sliding window. And as you can see here, the left pointers, yeah, left pointer, right pointer, we have already. So while the left pointer is on the left side of the right pointer, he keeps on moving. We keep on incrementing, and we, as you can see here, we're adding 1, or else we decrement the right pointer and return the answer. And one good example of that is defining the palindrome. So palindrome, as we remember, was when a string is a palindrome if the first and last element is the same, and it keeps on, the edges of the strings are the same. So that is a palindrome. And to solve a palindrome, we can use two pointers approach. And here we initialize left pointer as 0 and right pointer as the end of the string. And while left pointer is smaller than right pointer, the element the left pointer is pointing at, so array square bracket left, if it is not equal to the element that the right pointer is pointing at, we return false, because that means that the edges of the palindrome is not the same element if the pair doesn't match. So in that case, we continue the search if it is the same, so that when the pointer meets each other, if the pairs until then the pairs were all the same, then it means that all pairs match and it's a palindrome. So yeah, that was a pretty easy example of two pointers when there's only one pointer that we move. What if there's two arguments? So there were also two-pointer approach on two arguments, and that was still the same actually. Just 1 second. So here the pointer is initialized both as 0, whereas in the previous example, the left pointers were only initialized as 0. And we also initialize the answer as 0, like the previous example. We're going to store the result there. And the loop iterates as long as both I, which is for array 1, and J for array 2 is within the bounds of their respective arrays. So this is like checking the base case like we did in dynamic programming, right? So that if this doesn't suffice, then we can already quit the loop. But if that is true, if condition, so there will be some kind of condition, and if this condition is true, the pointer I is incremented. So you move on to the next element in array 1, or if not, then we move on to the next element in array 2. And we're gonna handle we then handle the remaining elements in array 1 after array 2 has been fully exhausted. So yeah, so we're going to perform some kind of logic on these remaining elements since array 2 has no more elements to compare. Same goes for array 2. When this loop runs, if there are any remaining, so if there are any remaining array elements in either one of those arrays, either this loop or this loop is going to run, right? And then this will allow us to perform operation on the remaining elements. And then we return the answer. And this was mostly used in cases like merging two sorted arrays into single sorted arrays, so that we don't have any remaining elements from two sorted arrays. We were also trying to find the intersection or union of two sorted arrays. And also we used it to compare elements between two sorted arrays to find common elements or differences. So one example was this find intersection. So we initialized I and J into 0, and then initialized also an empty array to store the results, which is an intersection. And while I and J is within the bounds of two arrays, we go through the arrays by incrementing the I and J. And if they are the same, the elements that the pointer I and J is pointing at is the same, then we append it to the intersection. If not, then we traverse the remaining arrays in array 1 or array 2. And then yeah, we see if there's any intersection in the remaining arrays. So yeah, that's no, if the array 1 is smaller, then I is incremented. Otherwise, J is incremented. So that was not exhaustion. The last one for today, was sliding windows. So sliding windows were when were we using sliding windows? So that was a common group of problems involving subarrays that can be solved efficiently with sliding window. So like first of all, like a problem will either define a criteria that will make a subarray valid, and there are two components. First one was there was a constraint metric, so there was some attribute of a subarray. It could be the sum, num of the unique elements, frequency of the specified element, or there could be numeric restriction on the constraint metric. So yeah. And also the problem will ask you to find valid subarray in some ways. Most common task you will see is like finding the best valid subarray. Or also like the example that we're going to explore quickly, the longest subarray with the sum at most, and they're going to give you the array and the target as an argument. But let's see the basic template. So we initialize the left a variable as a pointer. Here we're still using the pointer, and current a variable is like to solve the current state or value of the sliding window. So for example, some of the elements within that window, because we were just moving that window along the array, and answer, which is initialized to 0, which is used to store the result. So answer is always 0 in two pointers. So first loop, we iterate through the each element in array using the variable right, which represents the end of the sliding window, right? So the logic, it's told here to do a logic to add array right to current. So it will involve adding the element at array right to current, updating the current state of the window. So, and while there is a window, after it is added, a condition is checked to determine if a current window is invalid or needs adjustment. So if the condition is broken, the window is shrunk by removing elements from the left side, updating current by subtracting array left, as you can see there, and then left is incremented to move the start of the window to the right, right? So that's how we move the sliding windows, and then we return the answer. And we can see from the, yeah, typical use case was when we try to find the maximum or minimum sub of the subarray, or like this, we're trying to find the longest subarray with the sum or the shortest subarray that meets a specific condition. Here, like you can also see that yeah, left pointers initialized, current variable and answer also initialized as 0. And while the end of the sliding window is within that range, you add the current element to the running sum. And then if the sum exceeds the target, we shrink the window from the left, right? And then we add 1 to the left. And then that's how we move along the array. The answer variable is updated each time to track the maximum length of the subarray that meets the condition, as you can see here. And I remember this was max start of when we used max or min of answer of the condition to easily find yeah, the answer. But yeah, it was really powerful for problems involving subarrays, and I think it will be very useful. Well, it is proven to be useful. That's why I'm learning it. So anyways, yeah, that's the three algorithms that we quickly did an overview of. Tomorrow we're gonna move on to um, reviewing three more. I don't want to rush this, so yeah, we're just gonna review this bit by bit. Also, at my own time, I'm gonna see the template and then try to memorize them. Anyways, thanks for always accompanying me in this journey, and I'll see you guys tomorrow. Mm.